Dear students, today we will see the first and basic concept from optimization techniques, that is LPP, that is a linear programming problems that you have to solve using different methods like simplex method, big M method, dual method. So out of that we will going to start today the simplex method. There are two types of problems in case of simplex method. For simplex problem for maximization, simplex problem for minimization. So today we will see the maximization and afterwards we will complete the minimization problem also. So before solving a maximization problem, we will see some terminologies used in LPP. So in this example, see the example, solve the following LPP using simplex model and max z is equal to 12x1 plus 16x2. This is called as objective function. Max function is called as objective functions. Here we have to identify the values of x1 and x2 in such a way that the value of z will be the maximum value. Getting? So max z is equal to 12x1 plus 16x2. This whole function is called as objective function. So there are in different values. If you put the values of x1 and x2, you will get different values of z. So which are the feasible values or which are the correct values? Any value which fulfills the following condition or constraints. Means if you put that value in the constraint expression, that is the first condition of constraint equation is 10x1 plus 20x2 less than equal to 120. And second one is a 8x1 plus 8x2 less than equal to 80. So these 10x1 plus 20x2 plus 120 or 8x1 plus 8x2 less than equal to 80. These expressions are called as conditions or constraints. So any variable, any value of x1 or x2 which fulfills these conditions, these constraints, those values are called as feasible values. So there might be more than one values which fulfills the condition, this condition and this condition. Suppose if I put the value of x1 equal to 1, x2 equal to 1. So what is the value of x1? If you put the value of x1 into 1, x1 has 1, then 10 into 1, 1 plus 20 into 1, 20. So 20 plus 10, 30. 30 is less than 20? Yes, condition is true. Here also, value of x1 we have treated as 1, 1 into 8, 8 plus x2 is also 1, 1 into 8, 8, 8 plus 8, 16. So 16 is also less than 80. So value of x1 is equal to 1, x2 is equal to 1 is a one set of value. So if you put value of x1 equal to x1, x3 equal to 3, x3 equal to 3.1, 3.2, 3.4, n different values you can put. With the values which satisfies the given constraints, those values are called as feasible solution. Any values that fulfills the constraint, those set of values are called as feasible solution. Then what is the maximization function? So out of the set of feasible solution, the set of values of x1, x2 which maximizes the value of z, those values are called as optimum values. The values of x1, x2 which maximizes the value of z, that value of x1 and x2 are called as optimum values. So we have discussed the main max z function is called as objective function. The condition statements or conditions are called as conditions or constraints. Now the variables x1, x2, these variables are called as basic variables. Variables which are in objective function or constraint, those variables are called as basic variables. And the coefficient value, the 12, 16, 10, 20, 8, 8, these are called as coefficients of basic variable. So if you are very much aware about different terminologies used in LPP, you will be getting very easy to understand the process to solve the example. So first thing is objective function, second condition or constraint, basic variables and coefficients of basic variable. The next important part is that you have to check the symbols or signs in the condition statements or constraint statements. If the symbol is less than or equal to, then what this says that this expression is having something less in LHS side. That's why sign is less than or equal to. This expression is having something less to make equal to right hand side. So if you are adding something that adding is called as slack. That is called as slack. Getting? So here, to make these inequalities into equalities, if the symbol is less than equal to, then you have to add slack variable. For symbol greater than equal to, or symbol equal to, we have to add surplus variable and artificial variables. We will see in subsequent examples. But now what you have to take into consideration, in this example, the value is less than equal to, LHS is less than equal to RHS. So to make these equalities, you have to add slack variable. Now we'll start the example. What is example? First, you have to check whether the given problem is maximization or minimization. The problem itself says that the problem is maximization, because LPP using simplex method is only solved if the problem is for maximization. You cannot solve minimization problem as it is. If the problem is for minimization, then you have to convert that minimization into maximization. How to do that, we will see by another example. So in the given case, the problem is maximization, so it doesn't require to do any conversions. So given objective function is for maximization. That is true. And constraint function has less than equal to sign. So these are called as constraint functions. So these both are having less than equal to sign. So to convert inequalities of constraint into equalities, we have to add two slack variables. Why two slack variables? There are two constraints. So to make the first equation balance, we have to add first one slack variable. For second, we have to add another. So two slack variables are needed. If your example contains three constraints, three conditions, then still three variables might be needed. Getting? So number of slack variables depends upon number of equations, number of constraints in the given example. So in this example, two constraints are there. So two variables we have to add. But to adding the variables, you have to take some due care. What is that? Two slack variables in constraint. If you are adding that variables in a constraint, then we have to add coefficient of that constraint. Coefficient of that variable is equal to 1, and also the same variables you have to add in objective function, but at that time you have to add the coefficient value is equal to 0. So if you add these slack variables in objective and constraint function with provided coefficient values, you will get the LPP in standard form will be max z equal to 12x1 plus 16x2. Two variables we are adding, s1 and s2. The two expressions are there, so s1, s2, two variables are added, so that the constant equation becomes balanced. When you are adding slack variables in a constraint, the coefficient should be 1. So here 1 is there, but we cannot write that one here. In constraint, we have added s1 as a slack variable for first equation, s2 as a slack variable for second expression, and these same variables we have to add in objective function. But while adding objective function, these variables, you have to take care that the coefficient of that slack variables should be 0. So when you add this, you will get the standard form of LPP max z equal to 12x1 plus 16x2 plus 0s2 s1 plus 0s2 subject to 10x1 plus 20x2 plus s1 equal to 0, 8x1 plus 8x2 plus s2 is equal to 0, and the values of x1, x2, s1 and s2 must be greater than or equal to 0. So any value which are greater than or equal to 0, if you put in this equation, you will get max z value. So what are the best optimum value that you can use for x1 and x2 variable that you are going to calculate in this example? Okay, so from this initial simplex table for the given function will be how to draw a simplex table. Just take into consideration the blank values. Don't consider in what I have added in this example. So to solve the example, what you have to take into consideration? You have to check first what is my objective function. And in objective function, we have to identify the basic variables. So in the objective function, variables are x1, x2, s1 and s2. These are basic variables. So first we start from your basic variable. BV is nothing but basic variable from your objective function. So what are the basic variables in objective function? So x1, x2, s1, s2. So I have just added x1, x2, s1 and s2. So first I have started from basic variable identified by your objective function x1, x2, s1, s2. Then second we have to take into consideration that is CJ. CJ is nothing but coefficients of basic variable. So here x1 is my basic variable and coefficient is 12. So I have written x1 is a basic variable, coefficient is 12. Likewise, x2 is my basic variable, coefficient is 16. S1 is a basic variable, coefficient is 0. S2 is a basic variable, coefficient is 0. So we have identified values of BV and CJ from objective function. Likewise, which slack variables we have added, those variables we have to write here. S1 and S2, these two variables I have added. So I have to write S1 and S2 that we have added in my objective function S1, S2. And the coefficient values are 0, 0 that we have to write here. Coefficient values 0, 0. So the value slack variable S1 is added with coefficient value 0. Slack variable S2 is added with coefficient value 0 in objective function. Now what you will take, this S1 object, this slack variable is added in which function? This first constraint we have added the value of the slack variable S1. So now what you have to do, you have to take into consideration only this constraint or this equation. So in this case, is there x1 variable? Yes, we are having x1 variable. What is the coefficient of x1 here? Here value of x1 is 10. So we have to write here coefficient of x1 is 10. First you have to check s1 variable is available in which statement. Then from that statement you have to identify x1 variable and identify the coefficient of x1. So I have written here x1. Then is there having x2 variable? Yes. Then what is coefficient? 20. So 20. Is there s1? Yes. What is coefficient? 1. Is there s2? No. So we have to take coefficient of s2 as a 0. Then solution is equal to 120. So write as it is. Likewise, you have to check in which expression s2 slack variable is added. So x2 variable is added in second equation. So now we have to consider this expression only or this equation only. So what is coefficient of x1? 8. So I have written here 8. x2 coefficient is 8. 8. Here no s1 is there. So value of s1 is 0 we have to take. s2 is there. So s2 value coefficient of s2 is 1 as it is and answer is 80. So from the given expression we have prepared this table. We have prepared this table. Coefficient of basic variable identified. Basic variable identified, then coefficient of basic variables we have written here. Then we have identified in which expression we have added s1 and s2, and from that expression all the coefficient of x1, x2, s1, s2 we have identified. Likewise, in which expression we have added s2, of them we have identified coefficient of x1, x2, s1 and s2. So once you complete all these things, the next part start, that is calculation of zj. So how you are doing calculation of zj? To do the calculation of zj, formula is this value, because for the first cell we are calculating, this cell is related to this particular column. So this value is multiplied by this value. So 0 into 10 plus 0 into 8. So 0 into anything is nothing but 0. So we get 0 here. So here coefficient values are 0. So we will get all zj value is equal to 0. Means for calculating 0 zj, what is the formula? Column value multiplied by coefficient of slack variables or coefficient of basic variables. If you multiply these things and do addition of all rows, 10 into 0 plus 8 into 0, you will get 0. Then next part is the Cj minus Zj. So Cj is also we have given in example. Zj is calculated with the formula. Then Cj minus Zj. 12 minus 0 is 12. 16 minus 0, 0 is 16. 0 minus 0 is 0. 0 minus 0 is 0. Now how to check the problem optimality is reached or not? You have to check Cj minus Zj value for all basic variables. If Cj minus Zj value for all basic variables is equal to 0 or less than 0, then we can say optimality is reached. But in this case, the value of x1 variable is 12. Value of x2 variable is 16. So these values are not less than or equal to 0. So from the Cj minus Zj values, you have to identify the maximum Cj minus Zj value. So in this case, we have to compare value of all Cj minus Zj, and from that we can identify that the 16 is the maximum value. From Cj minus Zj, you have to identify maximum Cj minus Zj value, and here Cj minus Zj value is 16, which is maximum. So that column you have to select it as a key column. that column is selected as a key column. Also, it is called as entering cell. The cell, or we can say the variable, which is in that particular column, that variable is called as entering variable. Okay, the cell which is having maximum Cj minus Zj value is called as key column, and the variable which is in that particular column is called as entering variable. Always column variables are called as entering variable. Now we will see how to calculate key row. For that purpose, what you have to do? You have to divide the key column values with solution value. So here solution value is 120, key column is 20. So 120 divided by 20 is equal to 6. Likewise, 80 divided by 8 is equal to 10. So from the ratio values, we have to check which is the minimum ratio value. In case of column selection, we are seeking maximum Cj minus Zj. In case of row selection, we are selecting minimum ratio value. So here, minimum among 6 and 10 is 6. So this is my key row. The row which is having minimum ratio value is called as key row. Okay. Now, the variable which is in a row, that variable is called as living variable. In this case, this S1 variable is living variable, and intersection of row and column, or key row and key column. This is my key row, this is my key column, and where the intersection takes place of this key row and key column, this cell is called as key cell. We have identified key cell value. So what is the next procedure to solve this LPV problem? We have identified key row, we have identified key column, we have identified entering variable, we have identified living variable. So in this case, key column is, this column is called as key column, this row is called as key row, or column which is having maximum Cj minus Zj is called as key column. The row which is having minimum ratio value is called as key row. The variable which is in key column is called as entering variable. The variable which is in key row is called as living variable, and intersection of key row and key column is called as key cell. Okay, now see the formula. Now see the formula. Here, to solve this example, you have to make the key cell value is equal to 1 and other key column value is equal to 0. So you have to make this cell value is equal to 1. So how you can do this? So if you divide all values by 20, you will get this value equal to 1. The first starting rule is that you have to make key column value equal to key cell value is equal to 1, and key cell value is 20. So how to make 20 is equal to 1? If you divide by 20 to the key cell value, you will get value 1. So 20 divided by 20 is equal to 1. So to obtain this value 1 for the key cell, what you have to do? This is called as my first row. This is called as my second row. So this is my row 1. So what is the formula we have to use? For that you have to use one formula. We'll see. Okay, formula is new row 1. New row 1 is equal to old row 1 divided by 20. Now this is my first row. I want to make this value is equal to 1. So for that purpose, what I have to do? I have to divide all row elements by 20. So my formula is new R1 means, yeah, I am going to write new R1 here. So that new R1 is equal to old R1. What is old R1? 10. 10 divided by 20. 10 divided by 20. 10 divided by 20 is nothing but 1 by 2. Second, 20 divided by 20. Old value of R1 is 20. 20 divided by 20 is 1. Now, what is old R1? 1. 1 divided by 20 as it is 120. 0 divided by 20, that is 0. 120 divided by 20, that is 6. So you have identified the first row of new revised matrix. Okay. Now, what is your key cell value here? 1. So if you want to make this value 0, so what you have to do here? You have to subtract 8 from 8, then you will get 0. So for that purpose, what is key cell value now? 1. So if you multiply by this value, multiply by 8 to this and subtract from this, you can get this key column value is equal to 0. So what is formula for this to make this cell value 0? New R2. So this is my new row. This is my new row. If I want to make the values of okay. I want to make the value of this second row as equal to 0. Then what I have to do? I have to use this formula that old R2 means 8 minus 8 into new R1. What is new R1 now? 1 by 2. Suppose this is my 1 by 2. I will start from x1. So what is the old value? 8. This is old value. Old R2 is 8 minus 8 into new R1. New R1 is 1 by 2. 8 into 1 by 2 is nothing but 4. So 8 minus 4 is 4. Here old R2 is 8 minus 8 into new R1. New R1 is 1. 1 into 8, 8. 8 minus 8, 0. Likewise, to calculate what is old value of S1? Old value of S1 is 0. 0 minus 8 into new R1. New R1 is 1 by 20. 1 by 20. So what is formula? 0 minus 8 multiplied by 1 by 20. So it is 0 minus 8 by 20. 0 minus 8 by 20. If you divide numerator and denominator by 4, you will get minus 2 by 5. Likewise, here old value of S2 R2 is 1. 1 minus 8 into R1. Value of R1 is 0. 0 into 8 is 0. So 1 minus 0 is 1. 80. Okay. So what is the value? Old R2? Old R2 is equal to 80 minus 8 into new R1. New R1 is 6. So 8 into 6, 8 6 are 48. So 80 minus 48 is equal to 32. So we have calculated these new row values for first and second equation. For that purpose, what formula we use? New R1 equal to old R1 divided by 20, because the key cell value is 20 and we have to make this value 1, so we have to divide whole row by 20. Now I have to make this value 0, because this value is in the key column. All key column values must be 0. That's why I am dividing this variable by 8 and subtracting the new R1 value from old R1 value. When you solve this expression, you will get following table. So then next part is you have to calculate ZJ value. So how to calculate ZJ? 16 into 1 by 2 plus 0 into 4. 0 into 4 is 0. So 16 into 1 by 2 is 8. 16 into 1 by 2 is 16 by 2, that is 8. Likewise, 1 into 16 plus 0 into 0, that is 16. 1 by 20 into 16 means 16 by 20. If you divide numerator and denominator by 4, you will get 4 by 5. So 0 into 16 plus 1 into 0, that is 0. 6 into 16 plus 32 into 0, you will get 96. So once you calculated the ZJ values, then it is possible for you to calculate CJ minus ZJ, because CJ is already you are having. So just subtract value of ZJ from CJ. So 12 minus 8 is 4. 60 minus 16, 0. 0 minus 4 by 5. 0 minus 0, 0. Then you have to identify whether all CJ minus ZJs are less than or equal to 0 or not. We can find it is observed that this column is having value not equal to 0 or not less than 0. So we have to check which is maximum non-zero value. So this is maximum non-zero value. So this column is called as key column. Key column is a column which is having maximum Cj minus Zc value. That column is called as key column. And the variable is called as entering variable. Here x1 is called as entering variable. Okay. Then you have to calculate the ratio. Once you identify the key column, you have to calculate the ratio. For calculation of ratio, you have to divide the solution with the key column values. So 6 divided by 1 by 2. 6 divided by 1 by 2 is equal to 12. Then 32 divided by 4 is equal to 8. From these values, you have to identify which is the minimum ratio value. So has the row which is having minimum ratio value, that row is called as key row. And the variable which is in a row, that variable is called as leaving variable. So in next expression, you have to remove value x2 and 0 with the value of x1 and 12, because x1 is called as entering variable, s2 is called as leaving variable. So in place of s2, you have to add x2, x1, and at the value of coefficient of s2, we have to add the coefficient of x1. So the next iteration will be just we'll see here first. The s1 variable we have removed with x1 variable. So I have added here x1 and its coefficient value is 12. x2, that is as it is, we have to kept x2 as it is and value 16. Now what you have to do, we have identified this is my key element, because here key row and key column is intersected. So this is my key cell. To solve this example, what you have to say, what you have to do, we have to make the key cell value is equal to 1. So if you want to make this key cell value equal to 1, so what I have to do, I have to divide whole row by 4. If I divide whole row by 4, then it is possible for me to make this key value is equal to 1. So what is formula? The revised new matrix will be obtained by using following formula. New R2, because this is row 2. So we have to make this row, this key column or key cell is in which row, that operations you have to do first. So this is available in my second row. So I am doing operation on R2. So new R2, how we are obtaining new R2? New R2 can be obtained by dividing the old row by 4. So old row value is 4. 4 by 4, I will get 4 by 4, I will get 1. Then 0 by 4, 0. Then 2 by 5 divided by 4. 2 by 5 divided by 4. If I do solve this example, minus 2 by 5 divided by 4, then I will get minus 1 by 10. Getting minus 2 by 5 divided by 4 is nothing but minus 2 by 20. So minus 2 by 20 is nothing but minus 1 by 10. Then next one, 1 divided by 4, that is 1 by 4. Then 32 divided by 4 is equal to 8. Okay, once you identify the new R1, then what is the next rule? We have to make other elements of the key column is equal to 0. So if I want to do 0 here, then I have to subtract 1 by 2 from all elements of the first row. So what is the formula? New R1 is equal to old R1 minus 1 by 2 into new R2. If you want to make coefficient of this, if you want to make this cell value is equal to 0, then what we have to do? We have to subtract 1 by 2 from all elements, then you will get the value 0 here. So formula is new R1 is equal to old R1 minus 1 by 2 into new R2. So if you put the values, old R1 1 by 2 minus 1 by 2 into new R2. New R2 is 1. So 1 by 2 into 1, 1 by 2. Old R1 is 1 by 2. 1 by 2 minus 1 by 2, 0. Then next here, what is the old value here? 1. So you have to take here 1. Old R1 is 1 minus 1 by 2 into new R2. What was new R2? New R2 is 0. So 0 into 1 by 2, 0. And old R1 was 1. So as it is 1. Next, for here, old R1 is 1 by 20. So here 1 by 20 minus 1 by 2 into new R2. What is new R2? 1 by minus 1 by 10. 1 minus 1 by 2 into minus 1 by 10 is equal to plus 1 by 20. So 1 by 20 plus 1 by 20 is equal to 2 by 20. So 2 by 20 is nothing but 1 by 10. Getting? And last, here old R1 is equal to 0 minus 1 by 2 into new R2. New R2 is 1 by 4. So 0 minus 1 by 2 into 1 by 4. 0 minus 1 by 2 into 1 by 4 is nothing but 0 minus 1 by 8. So 0 minus 1 by 8 is minus 1 by 8. And last one, old R2, old R1, 6 minus 1 by 2 into new R2. New R2 is 8. So 6 minus 1 by 2 into 8. 6 minus 1 by 2 into 8. So 1 by 2 into 8 is nothing but 4. So 6 minus 4 is 2. So we have identified these values. Then we have to calculate Cj minus Zj. You have to calculate Cj minus Zj. So how to calculate Cj minus Zj? For that purpose, you have to do multiplication of this value into this value plus this value into this. So 16 into 0, 0 plus 12 into 1, 12. Likewise, 60 into 1, 60 plus 12 into 0, 0. So that is 16. So 16 into 1 by 10 plus 12 into minus 1 by 10. If you solve this example, you will get 2 by 5. Then 16 into minus 1 by 8 plus 12 into 1 by 4, you will get 1. Likewise, 16 into 2 plus 12 into 8 will get 128. The next part is you have to calculate Cj minus Zj. Cj is here, Zj we have calculated. So now do Cj minus Zj, 12 minus 12, 0, 60 minus 16, 0, 0 minus 2.5, minus 2.5, 0 minus 1, minus 1. Now you have to check whether all Cj minus Zj's are less than or equal to 0 or not. So in this case, all Cj minus Zj's are less than or equal to 0. Hence we can say that the optimality is reached. Now how to identify solution? You have to check the values of x1 and x2. And what are the possible values? What are the values for x1? x1 is equal to 8, x2 is equal to 2, and solution is equal to 120. So here all Cj minus Zj values are less than or equal to 0. Hence optimality is reached. And therefore x1 is equal to 8, x2 is equal to 2, and max z is equal to 120. This is my answer. X1 is equal to 8, x2 is equal to 2, and max z is equal to 120. So what are different feasible solutions? Out of that solutions, if you select the value of x1 equal to 8, x2 is equal to 2, then you will get value of z, that is maximum, and that value is 128. So in this fashion, you have to solve LPP using simplex method for maximization problem. If you have any doubts regarding how to use this example, how to solve the example, or how to use different formulas, you can call me on my mobile number. My mobile number is 98500 and my name is Dr. B.J. Mohite. Okay, if you have doubts, you can call me. We'll stop now. Thank you.